Hi everyone, welcome back to my channel. So today we will discuss a very classic approach which is asked in many interview questions, which is move zeros to end. So in this problem, we are given an array and it has some zeros or may not have some zeros. We basically have to push all the zero element to the end of the array and keep non-zero to the front. We need to maintain the order of the elements in the array. So on looking at this problem, a very basic idea should be there in our mind, which should be the naive idea that what we will do in this case. So we have an array and we want zeros at the end. So there needs to be a basic approach that we will think. Suppose in layman terms, if there is no coding, let's suppose. So what we will do? We will look from left side and we will see if there is a zero. Okay, this needs to be moved from here. We will put it out and we will shift the remaining elements to the left. A vacancy will be empty at the very end and we will put 0 there. So if I show this particular approach, so basically we have 0, 1, 0, 3, 12. Okay. So as soon as we looked at the leftmost, it is a 0. So we will move it out and we will shift all the elements to one step left. So it will become 1, 0, 3, 12 and this vacancy is empty. We will place the 0 here. In the next iteration, we will have this particular place to at the left. So we will look at it. It is non-zero. So we will move forward. This place next is 0. So again, we will do the same thing, which is put this out and move our elements to the left. So this is out and we will move our elements to the left, which will make it 3, 12, 0 and this will be placed at the last vacant position, which will be 0. Then our pointer was like here. Now we will see at this particular element and we see that this is a non-zero element and we will increment it. Finally, we saw that we have reached to the end and the side, these are already our moved zeros. So this is a very naive idea. So we should be able to write a naive approach also, basically to code up. This will build our coding habit. So if we should not ignore naive as such that, okay, this will, this we can code. Of course we can code, but we need to like build a habit of coding. Basically what we are thinking, we should be able to code. So for naive solution, what we are doing is that we are looking at the left part of the array. So we will place one loop, which will be I is equals to 0 to n. We can write this in any language. So this is the first loop and we will see if the current array element, which is I, is equal to 0. In that case, we need to perform some operation. So what is that operation? It is constant shifting to the left. We can also do this by swapping the adjacent elements. So what we will do is we will swap and push the 0 to the end. So we will write a loop for that also. So basically we will have j is equals to just next to the ith, which is I plus 1, to n, which is to the last, and we will swap. What we will swap? Array of ith element and array at index jth element. Okay, we will swap this, and once this the swapping is done, so this will give us time complexity of order of n square, which is not very optimized. So we need to optimize this approach. Other solution that will come to our mind, it can be using auxiliary space, by which what we will do is that we will take an extra array. So we will, in the extra array, whenever a non-zero element appears, we copy it to the new auxiliary array, and the remaining elements we fill with 0, and then at last we will copy all the elements in auxiliary array to the array which we have in input. But this also uses auxiliary space, which will take order n of space. So using extra space, we will have time complexity order n, but space complexity will also be order n. So we need something more optimal by which we can eliminate this usage of extra space. So if we observe in this question, what we want is the order should be preserved. We need in place, we need to solve this thing in place. We don't want extra space, and zeros need to go to end of the array. So this is a great fit for a two-pointer approach. So two-pointer approach also does things in place. So let's discuss the two-pointer solution. So the two pointers here, there will be a I pointer and a j pointer. What they will do is pointer I scans pointer j scans the array, and pointer I is the next position for the non-zero element. So let's dry run how this will work on this input array. So initially what we will have is, we will have our I pointer and j pointer at the 0th location. We will see if the location we are at, which is array of j, if this location is equals to 0. Is it equal to 0? Yes, it is equal to 0. In that case, what we will do is, we will move our j pointer forward. We will just ignore this element, and I will keep pointing at it because this is the next position for non-zero element. Then we will see the current location we are at with j pointer. Is it equal to 0? No, it is not equal to 0. So what we will do in that, we will keep this particular element at the ith position. So what we will do is, we will swap this. What we will do is swap it the arrayth ith location element and arrayth jth location element. So after this, what will happen is that we will have 1 here, 0 here, 0, 3, 12. So this will become our input. So now we have this. Now where should I go? Because I stores the next position for non-zero element, I will move forward. So I will be pointing here. So where the j was earlier, j was at this index, j will also move to next index, because this index is now having 0. So j will move here. So now again, j will see if this is a 0th element on 0 or not. So this is a 0, so j will move forward. Now the element pointed by j, is it a non-zero element? Yes, it is a non-zero element. Then what will happen? This particular element and this element will be swapped, and I will be moved forward. So basically, these two positions will be swapped. Okay. And this will become 3, 0 here, 0 here, and 12 here. Now the I will move also forward because this is a non-zero element. The role of I here is complete. I will move here, and j from here will move here. So j has reached here. Now is this a non-zero element? Yes, it is a non-zero element. Again, the swapping will take place, in which we will swap these two locations. So now the array will become 1, 3, 12, 0, 0. Now I will move forward, and j is out of bound. So now this result is the answer we need to return. So let's code it up. So what we did systematically was that initially we had our left pointer, which is I pointer, as 0, and we ran a loop from j is equals to 0 to n, basically n minus 1. And what we will do is that if the current element, which is pointed by j, if this is not equal to 0, in that case, what we will do is, we will do the swapping. We will swap the array I index and array of j index, and we will move our I location forward, right? So this thing will be done. And now with this, what will happen at last, we will have our zeros at the end. So this is the main code. This is LeetCode and this is problem number 286, move zeros. This is an easy category problem. So we have discussed the solution. Let's code it up. So what we have is, we will keep a pointer which is for the left, which is I equal to 0. We can also name it left as convenient. And now we will run a move. So j should be less than num store size. Now let's j plus plus. So a standard for. Now what we will see is, if the current element we are looking at, which is nums j, if this is not equal to 0, in that case what we will do is we will swap. So what we will swap? The nums I and nums jth element. These two elements we will swap, and we will do I plus plus because the rule of I is done, and j will plus plus from this loop. Now at last what we will have is, our move zeros will move coin. So this is the solution. Let's run it up and see if there's any problems. Okay, this is accepted. Let's submit this. So yeah, this beats 100% complexity. So far, we have used 2 pointers to modify array in place. In next video, we will use 2 pointers in a completely different way to find a pair efficiently in a sorted array. So stay tuned, subscribe to my channel. Thank you.